Welcome to video 4 for this unit on Pythagorean theorem and irrational numbers. In this video, we're going to focus on using the Pythagorean theorem. Is this a right triangle? It's hard to tell just by looking, and it may be that the sides aren't drawn to scale. It turns out that if we know the side lengths of a triangle, then we can figure out if it is a right triangle or not, using the converse of Pythagorean theorem. Say we have a triangle with side lengths A, B, and C, with C being the longest of the three. The converse of Pythagorean theorem tells us that if we have A squared plus B squared equals C squared, then we must have a right triangle. Since 8 squared plus 15 squared equals 64 plus 225, which is the same as 289 or 17 squared, any triangle with side lengths 8, 15, and 17 must be a right triangle. Together, the Pythagorean theorem and its converse provide a test for checking to see if a triangle is a right triangle, just using its side lengths. If A squared plus B squared equals C squared, it is a right triangle. If A squared plus B squared does not equal C squared, it is not a right triangle. In addition to its use checking right triangles, the Pythagorean theorem can be used to solve any problem that can be modeled with a right triangle where the lengths of two sides are known and the length of the other side needs to be found. For example, let's say a cable is being placed on level ground to support a tower. It's a 17-foot cable, and the cable should be connected 15 feet up the tower. How far away from the bottom of the tower should the other end of the cable connect to the ground? It is assumed that the tower makes a right angle with the ground. Since this is a right triangle, the relationship between its sides is A squared plus B squared equals C squared. Making substitutions gives A squared plus 15 squared equals 17 squared. Solving this for A gives A equals 8. So the other end of the cable should connect to the ground 8 feet away from the bottom of the tower. Another use for the Pythagorean theorem is to find the distance between any two points on the coordinate plane. For example, if the coordinates of point A are -2, -3, and the coordinates of point B are -8, 4, let's find the distance between them. This distance is also the length of line segment AB. Think of the distance between A and B, or the length of segment AB, as the hypotenuse of a right triangle. The lengths of the legs can be deduced from the coordinates of these points. The length of the horizontal leg is 6, which can be seen in the diagram, but it is also the distance between the x-coordinates of A and B, since the absolute value of the quantity -8 minus -2 equals 6. The length of the vertical leg is 7, which can be seen in the diagram, but this is also the distance between the y-coordinates of A and B, since the absolute value of the quantity 4 minus -3 equals 7. Once the lengths of the legs are known, we use the Pythagorean theorem to find the length of the hypotenuse AB, which we can represent with C. Since C is a positive number, there is only one value it can take. So C is the square root of 85. This length is a little longer than 9, since 85 is a little longer than 81. Using a calculator gives a more precise answer. The square root of 85 is approximately 9.22. Thank you for watching video 4 of 5 for this unit on Pythagorean theorem and irrational numbers.